Greetings of the day. I hope you all are doing well. I am Nivya George, Assistant Professor, Department of Forensic Science from Kristu Jayanti College, Bangalore. Today I will be discussing on the topic volatile and non-volatile memory, which is part of digital forensic science. So first we will see about both the memories. First one is volatile memory. So volatile memory requires power to retain the data. That is, when the power is cut off, the data will be erased or the data will be lost from the memory. So it will retain its memory only when the power is there, and it is a temporary storage. So it only stores data when the power is on. Once it is off, it will be removed or erase the whole data. And compared to the non-volatile memory, it is faster in read and write procedures. So the moment we on your system, whenever you are opening your phone or your whatever digital device, your data from the main storage will be stored into the RAM. So that is where it means maybe it will take fraction of seconds to store. That much faster it's the volatile memory to load. Then we will see few examples. One is the RAM. Then we have cache and register. So the main use of us, it is to store the data and instruct the system needs to access quickly while it's operating. So whenever you are doing a work, whenever you are opening an application, or whenever you are working in a software, all the softwares are first loaded into your volatile memory. Mostly in case it is RAM. So from the RAM only it starting working, or it will do its own work. And when the power is down, whatever data is stored in the RAM will be removed or lost. Next one is non-volatile memory. So non-volatile memory is just opposite to your volatile memory. So it doesn't need any power to retain the data. Whatever we are saving in your hard disk or SSD are the non-volatile memory. So those are permanent data storage. And it is slower in the read and write time, because we are mostly we will be saving a larger data. So it takes little time to read and write it, as well as to store into the RAM. Then we see some examples. First one is ROM, then EEPROM, that is electronically erasable programmable ROM, that is a new advantage version. Then HDD and SSD, which is your permanent storage in your laptop most of the cases. Then flash memory, which are your SD cards or your pen drives. Then we see the use of your non-volatile memory. So main use is to store all the data. So we need to store maybe my user file or some software operating system or some applications. So all this we will be storing in the non-volatile memory of the system. So hope you all remember the difference. The main difference between this is the one, your volatile memory needs the power to retain the data. Non-volatile memory doesn't need the power to store the data. Then volatile is a temporary one. Non-volatile memory is a permanent one. Volatile memory is faster compared to non-volatile memory. Now we will see how to seize a volatile memory. So the first step is to identify the system's volatile memory. So first we have to identify which system you are going to seize. In that you have to identify which type of volatile memory is present. Maybe it can have RAM, or maybe you want to take a cache or a register. So that you have to identify. And if it is a RAM, physically you have to locate the where inside your electronic device, where the system your RAM is situated. So you have to locate it in the system. Then you can seize it. Then you can use some specialized tools to seize it. So few tools are like FTK Imager or Magnet RAM Capturer or Volatile framework. There are many softwares which can be used to capture all the RAM memory, all your volatile memories. Then you can do a proper capturing of your memory using any of the tools which you are comfortable with. So once you are done capturing, either you can go for a proper capturing or a live capturing can be done. So when you are doing a live capturing of the data and running process, you have to make sure that whatever data is or whatever application is currently using or running, all that you have captured to your memory, or whatever is there you are capturing it properly from the memory. Then you should avoid all the alterations to the content. So this is a main part in the forensic science. Whatever data you are seizing or whatever data you are acquiring, you have to make sure that you are not causing any damages to the data. If you make any damages, you are altering or modifying the data, that will not be admissible in the court. So whenever you are taking or seizing or doing acquisition imaging or RAM capturing, make sure that you are not altering any of the data that you are getting from the original memory system. Now we will see how to do seizing of your non-volatile memory. So first, same as the volatile memory, we have to identify the storage device. So here it can be either a hard disk or a SSD or a flash drives, or maybe a USB or SD card you will be getting. So you have to locate that in the electronic device. Then you have to create a forensic imaging. So forensic imaging is the process of making a bit by bit copy of your original storage device. So each bit will be copied exactly, you will copy it same to the another sterile device. So that process we call it as forensic imaging. So for all non-volatile memory, we are doing forensic imaging to preserve the data as well as to keep its integrity. And one another purpose of doing forensic imaging is that we are not supposed to work on the original data. So since there is a case that we are not supposed to use it, we need some other data or a package to do it. For that, we will be taking a forensic imaging of a original device. It can be one imaging you can do, or if you want, you can go for a multiple imaging and you can save it for your future analysis. So there are many other specialized tools like FTK Imager, NCase, DD, Belkasoft. So depending upon your specialization, again you can choose any. If you are comfortable with FTK, you can go for FTK. NCase you can choose, or based on your investigation company or the lab you're working, you can choose any of the specialization, any of the tools which is using for forensic imaging. So you can do the forensic capturing. There also you have to make sure you are not making any alterations to your original data. So for that, we will be using a write blocker to prevent writing onto your original data. Then you have to verify the data. So whatever data you are getting, you have to go for hash value comparison. So most of the cases, FTK, NCase and all will give you a automatic hash verification. So once you are done with your imaging, they automatically give you a summary of your hash values. So that you can submit to the court if you want, or you can use that to compare with the original hash and the hash value you got after imaging. Then after, you have to secure the forensic image. So most of the cases we will be using a sterile device to store our forensic image. We will not use any old one or pre-used storage devices. We will be using a new device. Maybe if you are taking a pen drive of 4 GB, another new pen drive of 4 GB we will use to store the imaged data. So you have to store it properly, ensure that we are not tampering or making any alterations in the imaged file also. So now we reach to the conclusion. We are again recapping whatever we have studied so far. First one is volatile memory. So we told it is a memory space where data is stored only when the power is on, and non-volatile memory is when the data is stored without any power. Then we have studied about the seizing of the volatile memory as well as the seizure of non-volatile memory. So in the seizing of volatile memory, we will identify it, we will capture the RAM or registry or cache. In non-volatile memory, we will be doing a forensic imaging and we will verify it using the hash value. So I hope you all understand the topic.